Mathematics is a powerful tool in physics. Physics without mathematics could not exist. But we have to understand one thing, that a mathematical description of a given physical phenomena is not necessary physical equation. We have to understand that there is a big, huge difference between mathematical equations and the physical equations. This is one of the main subjects of biactive research methodology. That's why I founded a private institute, Biactive Physics Institute. A mathematical equation, or we can even say mathematical description, is not necessary a physical equation. Let's take one example that is very obvious, very clear to everybody, if he or she won't understand. Einstein general theory of relativity. Einstein field equations. Gravity tensor of Albert Einstein is today recognized as the most exact description of gravity. But we have to understand that this is not physical equation. This is mathematical description. After 100 years, theoretical physicists are not agreeing yet on which units has Einstein tensor, because every physical equation has units. We know that we measure forces with newtons. So gravitational force we measure in newtons. But for the Einstein gravity tensor, we don't know, it is not clear which are the units. The Newton equation, the Newton description of gravity, is physical equation. Okay, this is a physical equation. What we did, our research group, this physical equation you see, this is a physical equation. What is the Einstein idea of gravity is that matter is curving space and that this curved space carry gravity. So there is no directly gravity force between two material objects. This is Einstein's proposal. This has to be understood profoundly. But as NASA measured in 2014 that universal space has Euclidean shape, we have to go on with our understanding of gravity, because this means that the curvature of space is only a mathematical description, it's not a physical formula. So, my idea years ago was, and we are now developing this together in our research group, that every physical object diminishes energy density of superfluid space in its center exactly for the amount of its mass and correspondent energy. This means the extension of the mass-energy equivalence principle on the superfluid quantum space. Okay. So, in the interstellar space, intergalactic space, the energy density of superfluid quantum space is a Planck energy density. Where we have a star, the energy density diminishes, but the average amount of energy in every point of universal space is a Planck energy density. Now we have here practical applications. Light, when passing the stellar object, is not bending because space is curved. Light bends because of the variable energy density of the space. In the center of the sun, the energy density of space is much lower than on the surface of the sun. And light, when approaching, if my head is the sun, light when approaching the sun is moves towards the area with the lower energy density, and when light is leaving the sun, the energy density of superfluid quantum space is increasing. This variable energy density is a physical origin of light bending. It's a physical origin of change of the refractive index. So what we did actually, we replace mass 1 and mass 2 with the gravitational mass. And we have to understand that gravitational mass is not a mass. Also, inertial mass is not a mass. Let's say rest mass. Every rest mass is interacting with the superfluid quantum space and diminishing energy density exactly for its amount. And this is inertial and gravitational mass. So when we have two physical objects, they diminish the local energy density of superfluid quantum space, and the gravity is a pushing force from outside. I know this is something new in physics, but it makes sense. Curvature of space, after NASA has discovered that space has Euclidean shape, is a mathematical description that belongs to the history of physics. And I believe that this will slowly enter the mainstream if we want to progress physics. If we want to stay in the past century, then we can still play in the infinity with this Einstein mathematics, and we will not arrive anywhere. In 100 years, there is no progress in gravity. And you cannot calculate the gravity force between Moon and Earth with the Einstein equations. So what is the purpose? Actually, I say wrong, not with the Einstein equations, with the Einstein mathematical description of gravity. Because basically there are not equations there. We know very good what does it mean, equation in physics. This is the point that I started this video. Mathematical description and physical equations. So the below is the link of the article that now we have in the peer review with my student Akash Saroy from India, and we hope that we will receive a fair peer review.